Well, you might say it's one thing running file system checks and monitoring the file system, but of course above the file system you have the actual disk or the disk partition itself. So we can independently monitor the hardware from our file system, and this is done through the self-monitoring analysis and reporting technology. Phew, it's a bit difficult to say, but SMART is a lot easier. If we install the smartmontools, so this would be on an Ubuntu based system, it would be apt-get install smartmontools. On our Fedora, Red Hat, CentOS systems, it's going to be yum install smartmontools. So with this installed, it's going to give us two commands. There's the interactive command smartctl, along with the smartd or the smart daemon that then can run checks within the background. So the smartctl, we can go through and interactively run our own checks. Perhaps periodically we want to check the health of a disk, but we could also return information about the disk, such as the spindle speed, those sorts of things. Whereas a smart daemon is there to run in the background, so we can have alerts when conditions perhaps indicate that a disk failure perhaps is imminent. Let's take a look at installing and using SMART on the CentOS 7 system. So working on the command line of our CentOS 7 machine, we can use yum to install the smartmontools. So we can go yum install -y and then smartmontools. We see on this system it's installed, but it's worth knowing if it's on your system it may not be. And of course if we're using a Debian based system or Ubuntu, we're going to use apt-get and install. But once we've got it installed, it's going to give us these two commands, the smartctl and then the smartd. So if we look at the interactive commands, so we can run tests ourselves, and we can run smartctl and then -i for information, and then the device that we want. Remember, this is going to be a disk, not a partition really, so /dev/sdb. And we can see that the vendor and product information then comes back as VMware, as this is a virtualized system. The rotation rate, the spindle speed if you like, shows as a solid state device, but that's really picking up from the system that it's running on rather than the disk itself, because this is a virtual disk. A lot of the other information isn't going to show because this is a virtual disk, so we've only got limited vendor attributes that are available. If we look on a physical drive, we're going to get more information coming back. So let's then use SSH to connect into my own system on the internet and use smartctl to display that information. So we can use SSH to connect as Andrew, and then going through then to my systems, RH Labs, and then the urbanpenguin.com. And of course we need to put in the password. With this system it's a little bit stronger than just password 1, I can assure you. And now that we're in, we gain some administrative privileges, and then we'll be able to run the commands. So let's run the same thing where we're going to retrieve information about our disk, but this time it's going to be dev sda, and we spell dev with a V. So with that now set, we can see that the model family this is coming from is HP, and we've got a device model and serial number. We can see the logical unit, the LUWWN device ID, so the worldwide number is really a unique identifier in very much the same way as the MAC address to a network card uniquely identifies that network card. We can see the size, 250 gigabytes, and then its rotation speed, 7,200 RPM. Then we're getting a little bit more information coming about the interface that we're using, so the ATA and SATA interface and the supported speed and versions. So we can see there's a little bbit more information depending on the attributes that are supported by the vendor. So let's just jump out of this system now and return back to our CentOS 7 system. So back on the CentOS 7 system, again, if we revisit the smartctl, and we can actually go through and run a health check. So again, using the interactive command smartctl, we can use smartctl and -H and the device name, and we can then report on the health of this device. And of course it shows that it's okay, which kind of you would expect being a virtual disk. But this gives us an insight into some of the commands and options that can be used to monitor the health and integrity of the physical device. But of course we could schedule this to happen and have it run in the background. If we want to do that, this is where then the SmartD comes in, and it's got its own configuration file that we can access within the etc directory. It may differ on your system, but on this CentOS 7 system, it's in etc / and then smartmontools. So if we go into this directory and take a look, we can see then that we've got the smartd.conf. If we take a look inside the configuration file, it's here where we can then go and specify what devices we want to scan and what options we want to be included. So again, it's reasonably well documented, and it says that it can identify the disks that we have by looking at our proc file system. If it detects a line with device scan, then everything else is going to be ignored after that device scan line. So as they say, very often we actually comment that line out and then include our own directories with exactly what we want. We can follow our way down through the file to get an idea of some of these, and they give us, if you like, text explaining what's happening and then the options. And we can include options to mail ourselves, so a root or external accounts, if that's enabled. But there's lots of things that we can then do to interactively monitor this hardware. Let's return now to the slide so we can summarize this module.